Hello everyone, my name is AMMAJI DUPPADA, and here so far we have seen how to solve linear differential equations of higher order. In that we have seen the complete solution of any differential equation is equal to complete solution is equal to complementary function plus particular integral. It means sum of the solutions of complementary function and particular integral is equal to whole solution of the given differential equation or given system. It means if you find CF only, then it is not completed. You have to find particular integral also. So far we have seen many methods. In that we have covered how to solve a particular differential equation in that complementary function. So there are some methods are there in that complementary function. Particular cases we have solved. Now this part is over in the previous videos. Now we are seeing how to solve a particular integral. So in this, generally we know a general form of differential equation, which is very practical, is this form. That you can write as f of d is, it means f of d is a function of derivatives or function of d terms or differential coefficients operating on y is equal to x. Here y is output, capital X as an input, f of d is the function of derivatives of it's a higher order differential equation like d square plus 2d plus 2, like that f of d will come. So now to solve particular integral, there are some methods, there are some cases, especially in that. What is the difference then? So to solve a particular integral, firstly we need to understand particular integral means reversal of the derivative. It means here f of d is a function of d terms, nothing but derivative terms. So particular integral means you have to operate 1 over f of d. It means reversal of the derivative, nothing but integration. You have to operate on x, because I told you while solving complementary function, we made input as 0. It means we made capital X as 0. And we make f of d is equal to 0. Then we get some roots. Based on that type of roots, we found how to write complementary function. But coming to particular integral, you have to operate 1 over f of d on input. That's why it is called complementary function is called zero input response. This is particular integral called forced response, nothing but external response, because we are giving input externally. That is called capital X. So this we have to solve. Now, why then 5 cases will come in this particular integral? Because X is the input, maybe different forms. X is input, can be given in different forms, So based on that form, we will solve particular integral method. So now we will see what are the possibilities of x. Now case 1 I am writing, capital X is an input, it may be e power ax. If capital X, nothing but input, is in this form, it may be e power 3x, e power 4x, e power 5x, any form like that. If that is the case, how to write particular integral? Simply you do 1 over f of d. You know that what is f of d? In the question they will give, you operate on e power ax. So how to operate? Just simply you put in the place of d, you put a. It means put d is equal to a. It means 1 over f of a. That's it. Your operation is done. This is particular integral. But one case, 1 over f of a should not equal to infinity. It means f of a should not be equal to 0. If f of a is equal to 0, 1 over f of a is equal to infinity. That is undefined case. So if it is not happen, then this is answer. First, suppose if f of a is equal to 0, what you have to do is you multiply with x. F of a you have to write like f dash a e to the power ax. It means what you have to do, simply you have to do differentiation of the given function f of d, and then you put d is equal to a but multiplied by x. That's it. This is the output. But here also one condition is there. F dash a should not be equal to 0. So if f dash a is equal to 0, then you have to write, you have to multiply with another x square 1 over f double dash d you have to calculate, then you put d is equal to a into e power ax. That's it. This is the output. So again here also is the case, f double dash a should not be equal to 0. It means this thing will repeat x square x cube like that till where you get f denominator not equal to 0. Till that point you have to continue. This is the case 1. What is the case 1? Simply I repeat, if x or the input is in this form e power ax, then simply put d is equal to a and into e power ax. That's it. It means you have operated 1 over f of d on e power ax. That's it. But f of a should not be equal to 0. If f of a is equal to 0, you have to multiply with x. 1 over f dash d you have to differentiate once the whole function, and then you operate on e power ax. If it is f dash a is equal to 0, then repeat. So this is the case 1. Now we will see case 2. If input is in this form, if input is sine ax plus b or cos ax plus b, for sinusoidal function like, then simply you cannot operate 1 over f of d on this functions like, let us say I am taking only sin x plus b, but same thing will is applicable for cos ax plus b also. Now what you have to do is, your given function f of d you have to write in this form d square terms. Then you can put d square is equal to minus a square. It means here a is there. It means 1 over f of this, in the place of d square you have to put minus a square into sin ax plus b. That's all. It means you have operated 1 over f of d square on sin ax plus b. That's it. That is the answer. Here also condition is f of minus a square should not be equal to 0. If is the case, if f of minus a square is equal to 0, then what you have to do, you simply put x in the beginning, you have to differentiate the whole thing. You have to do f dash d square, you have to operate on sin ax plus b. Again you have to put here also d square. Now you have to, what you have to put, minus a square. It means x into 1 over f dash, in the place of d square you have to put minus a square into sin ax plus b. That's it. It means you have operated this 1 over f dash d square on sin ax plus b. Like this you have to repeat till denominator is not equal to 0, because if denominator is equal to 0, automatically it will be undefined. So this is the case 2. I told you same thing is applicable for cos ax plus b also. Now case 3. If capital X is equal to x to the power m, it means x cube, x square, x power 4, whatever the function is like. So you have to operate 1 over f of d integral operator on the on input x of m. So in this case what you have to do, f of d you have to take numerator side. It means f of d inverse will come. Simply you operate this function on x power m. It means here f of d, you will get an expression that you can operate on x power m very easily. But here one thing you have to understand, let us say f of d is equal to, if f of d is equal to 1 to the 1 plus x, it means f of d inverse is 1 plus x whole to the power minus 1. It means 1 minus x plus x square minus x cube plus x to the power 4 and so on. It means, now see, if you put this f of d, nothing but f of 1 plus x or 1 plus d, you can say. This thing you have to operate on x power m. You can easily operate. Let us say f of d is 1 plus d. 1 plus d inverse. It means 1 minus d plus d square minus d cube plus d to the power 4. You have to operate on x to the power m. It means 1 on x power m, nothing but x power m only, minus differentiation of x power m, m into x to the power m minus 1 plus 2 times differentiation. You know that how to do that. So simply each operator, each term you have to operate on x to the power m. That's it. You will get a solution. This is case 3. But one thing you have to understand here, some expressions you have to by heart, like 1 plus x whole power minus 1, 1 minus x whole to the power minus 1, 1 plus x whole to the power minus 2, 1 minus x whole to the power minus 2, 1 plus x whole to the power minus 3, minus 4, like that. So if you know the basic binomial formula, you can write any function. You no need to by heart, like x plus y whole to the power n is equal to nc0 x to the power n minus 0 y to the power 0, nc1 x to the power n minus 1 y to the power 1, nc2 x to the power n minus 2 y square plus and so on, ncn x to the power n minus n nothing but 0 y to the power n. It means if you know this expression, any expression you can write by using this form, this generalized form, that you have to operate on your x power m input. This is case 3. Now case 4. If x is e to the power ax into v, v is some other function. It may be any function, like it may be sin ax, cos ax, or x power m, whatever it is like. If that is the case, 1 over f of d how to operate on x, nothing but e to the power ax into capital V. You simply put d in the place of d, you put d plus a. In that case, you can bring e power ax left hand side. It means e power ax, you no need to operate f of d 1 over, but in the place of d you have to put d plus a. Now you operate on v. It means firstly you have to operate 1 over f of d on e power ax into v. Now when you put d in the place of d, d plus a, if you put, you no need to operate on e power ax. E power ax you can bring left hand side. Now only you need to operate on v. V may be any function, like we know it may come under case 1, it may come under case 2, it may come under case 3. You know how to solve case 1, case 2, case 3. If v is case 1, if v is case 2, if v is case 3. That's it. This is case 4. Now case 5. Actually case 5 is general case. If x is other than given and it is general case, it can apply on any case. X is other than given 4 cases. Given 4 cases. And one more thing I told you, it can apply on any case. On any case, you can apply this thing. So how to do this? First, suppose 1 over f of d is operating on x. Here the case is, this thing you have to resolve into partial fractions like that. It means f of d you resolve into partial fractions. F of d you have to resolve into partial fractions. In that case, for suppose you are getting like this: 1 over d minus a plus 1 over d minus b plus 1 over d minus c, or d plus c, whatever it is like. Like this you will get. Now you have to operate each term on x, because 1 over f of d you have divided into partial fractions. F of d you resolved into partial fractions. In that case, you have to operate each term on x. How to operate on x? So one general formula I am writing here: 1 minus 1 over d minus a operating on x is equal to direct formula e to the power ax into integration of x into e to the power minus ax dx. That's it. This is the solution. Now in this video, if you understand, we have seen 5 cases. Yeah, we have seen some cases in solving complementary function. So in this 5 cases, what is the thing which is varying is input, what we are giving externally to the differential equation or any system. If input is different, varying, your case will vary. In each case, you have to do a different methodology. You have to apply a different methodology to solve the differential equation. So now you may think like, how we are writing this? In this case, why I need to put d is equal to d plus a? Then how this e power ax is skipped? So you may think that. So if in order to understand that, you have to read proofs against each case. But one thing you remember here, in the particular integral case, you are operating on input, externally given input, with the inverse differentiation, nothing but integral operator 1 over f of d, that you have to operate on your input. So based on the input, we have seen different cases. So in the next video, we will see some proofs, how we are writing these things, and then we will see an example. Thank you all for watching this video.